Alright, welcome back to this video series in which we talk about the different hyperparameters of training a neural network and the considerations we need to take when developing a neural network model. In this video, we'll talk about the effect of the epoch count in the training process. Now, you may think that the more epochs we train the model, the better the result will be. Unfortunately, it's not as easy, but I'm here to explain how you should choose the epoch count and how to interpret the results. First, let's answer this thought that the more epochs, the better the network will be. This statement is inexact. The more you train your network, the better it will be at estimating the training set that you are working on. If this is not the case, your network is either underfitting or the architecture that you choose is not fit for the task that you have in hand. You can visualize your network output to see how it is solving the problem, which is, by the way, an absolute necessity when you're doing a more serious project. But before you get there, you can always check the loss value or average of your outputs. A model that is trained incorrectly will decrease the loss in the first epochs. In these steps, the loss trend should drop sharply. Then at some point, the training loss will start oscillating and dropping with a lower slope. Now, let's discuss when you should stop training your model. You might have heard that you will plot the validation loss and stop when the validation loss start increasing, as it shows that your net model is starting to overfit. Again, this statement is also inexact. The validation loss correlates most of the time with whether your network is overfitting or not, but it is not the only indicator that correlates, nor the one that you should use to stop training the model based on that. You have to choose a metric that shows how well your results are, and when you see that metric degrading, it is time to stop the training as your network is starting to overfit. For example, in one of my previous projects, I was transcribing the phonemes of an audio file, and the metric that I chose was the edit distance between the model's inference and the actual true label. In the last 3 epochs, the validation loss was actually increasing, but the edit distance was decreasing. So I kept the model that had the least edit distance. Now, moving to the example of this video, I want to estimate the sine of 6x. I kept all the parameters constant except for epoch count. So let's run the code and see how the model will perform under these conditions. Okay, as you can see, the model does a very poor job at estimating the function after 1 epoch. But as the epoch count increased, the estimation becomes better and better. This example here is too simple to demonstrate more advanced concept that we talk about in this video, but I will make other series to go in depth on how to optimize and tune networks for real life problems. So subscribe to the channel and hit the bell icon to be notified if you want to see more contents on deep neural networks and data science. In the next video, I will go over the effect of learning rate and how to tune it. If you enjoyed this video, please give me a thumbs up so others can find it on YouTube as well.